Welcome to the project demonstration of underground cable fault identification and alerting system by using IoT. So the main application of this project is whenever we are transmitting the power from one location to another location based on underground cables, then there will be chances of short circuit. That may be line to ground, line to line, open circuit. So in our project we are concentrating to find the line to line fault. So means when the total 3 cables are attached in one socket and sending the cable to the underground cable connection, then if is any line to line fault occurred, based on the voltage fault reduction in the receiving section, we are going to estimate the distance. So that will be based on the length of the wire. So here for demonstration purpose we are using the 10 kilometers, 20 kilometers, 30 kilometers of transmission fault identification to the line to line fault. So in that one, so how we are going to estimate the 10 kilometers, nothing but we are using the 10 kilo ohm resistance by assuming the 10 kilometer distance of wire consuming the resistance of 10 kilo ohm. That's why we are using the 10 kilo ohm resistance here. So which will indicate it directly resistance is parallel to the length of the cable where we are going to transmitting the power in underground power transmission. Same for the remaining 2 phases, like RYB we are using the power is transmitting from this section and we are going to receiving this section. So sorry, this is the transmitter section. So from this main distribution way, and from there this is a receiving section. So from there the Arduino is placed to measure the voltage. So in real time directly we are going to measure the 230 volts, but now for demonstration purpose we are making use of a 5 volts transmission at this section and receiving is 5 volt at the microcontroller, this Arduino Uno board. So whenever the voltage drops, so that is based on the resistance, nothing but length of the wire. So whenever the line to line fault occurred, the voltage will be drops the respective sections. So we have interface that A0, A1, A2 pins, and these are the main input to the system, and from there the data will be displayed on the LCD continuously about the status, and same data will be sent to the mobile phone through this ESP8266 Wi-Fi module. In our mobile phone application we can access the data. So in the whole system the main power supply is getting 230 volts AC input, so that is parallelly given as input to the 3 loads through this electromagnetic relays. So these 3 relays will acting as a switch, and the operating voltage to our microcontroller is 5 volt. So in order to make that 12 volts AC which is coming out from the transformer to the 5 volts of DC with help of this regulated power supply board, so which has rectification, filtration and regulation. So after these three stages we will get the 5 volts DC output. So that is the main operating voltage in our microcontroller Arduino Uno board. So let us see demonstration. Before demonstration, first of all we need to install Juice SSH application and then network analyzer application. After installation of these 2 applications, go to hotspot settings of your phone, configure the hotspot name to project 7144 without any space, without any capital letter. Password should be 123456789 and the band should be 2.4 gigahertz. And on the hotspot, now we can on the power supply to the kit. So welcome message will be displayed on the LCD screen. So we'll show you that. So whenever everything is normal, then 3 relays on state and status is normal on the LCD. Now we can see the one device is connected in your mobile phone. So in order to get the IP address of our mobile phone, options, LAN scan, otherwise directly if it is showing like this, no Wi-Fi, then in the hotspot settings only click on the ESP. There we get the IP address. See that 192.168.251.201. So I'll show you from starting onwards. Right. So once we open the application, manage connections, add the connection. So type telnet, address is so which we got from that settings 251.201. 251.201. Right, and the port number is 8080. Done. Click on that. There you can see the status normal on RYB phases continuously. We are getting that in our mobile phone. Right. Okay. So let us fault anything like here. If you make any short circuit occurred, then at the receiving section to the 10 kilometers of region on the LCD also to show you that BR fault, the line to line fault at 10 kilometers. Same error message continuously on our mobile phone. Again when it is normal, back to the normal, again relay gets switched on and the status normal on the LCD as well as on our mobile phone. So if randomly fault occurred, right, 3 at RYB and in that YB, BR and RB, right, so you can see that. So BR and RY and YB faults on LCD, you can see that. Same data on the Wi-Fi hotspot like SH client application, 10, 20 kilometers, 30. So if you make this, so 3 also can be identified directly. Right. So in this manner, underground cable fault identification will be achieved. Based on the length of the wire concept, voltage will be drops, and length of the wire resistance will be increased. So based on the concept, we are going to identify the fault in underground.